Okay, 4.2, greatest common factor. Okay, greatest common factor. To know how to find the greatest common factor, you got two different ways to do it. All right. So, two ways to find the greatest common factor. First way, and we're not going to use this way, but you do need to know that this is one way to do it. First way to find the greatest common factor is to list all the factors of the numbers you are given. So, for example, I'm given 20 and 32. I want to know the GCF of 20 and 32. Okay, so if we're doing it the first way, then you would just simply take 20, 1, 2, 4, 5, 10, 20, and you would take 32, 1, 2, 4, 8, 16, 32. Okay, and we would see which ones are the same. Obviously, every single number is going to have 1 as a factor. Okay, that's why we're looking for the greatest common factor. Okay, some people will call it, especially like on the internet, places like that, they may call it the GCD, the greatest common divisor. Okay, because that's what you're looking for. You're looking for a number, the greatest number that will go into both numbers. Okay, but on this, we also have 2 is common, 4 is common, and that's it. Okay, so the greatest common factor of 20 and 32 is equal to 4. Okay, now that way works as long as you can, as long as you're good at listing out factors and doing it fairly quickly. Okay, the problem is, from looking at some of your homework from Friday, most of you were not able to list all the factors. So if you don't list all the factors, you may leave the greatest common factor out of the problem. Okay, so I'm going to show you the second way. The second way to do it is by prime factoring both numbers. Okay? Then following the steps. Okay, so this one's a little bit, I'm going to detail it more as far as words go, because this is the way that you need to know how to do it. Okay, this is the way that you're going to be required to do it, regardless of what it tells you in the directions of your work. Okay, so let's say that we're finding the greatest common factor, the GCF of 24 and 32. Very similar to the problem we just had. We had 20 and 32, but this is 24 and 32. Okay? What we would do, first of all, step 1, prime factor both numbers using either factor tree or inverted division. Okay, so I've got a prime factor 24. I'll do it with the factor tree. It gives me 6 times 4, 2 times 3, 2 times 2. Those are all prime. Now I'm going to prime factor 32 using inverted division. 2, 16. Remember, everything outside the parenthesis, outside the bracket in inverted division has to be prime. 2, 8, 2, 4, 2, and 2. Step 2. Well, actually, this is still step 1. So the prime factorization of 32 is 2 times 2 times 2 times 2 times 2. Prime factorization of 24 is 2 times 2 times 2 times 3. So step 2, list the prime factors that are common in both prime factorizations. Okay? So which ones are common in both prime factorizations? What? 2. It's the only one that's common. Okay? Step 3, find the number of times the common prime factored is shared in both prime factorizations. Okay, so we have 2. It's shared once, it's shared twice, it's shared 3 times. The number of times the prime factor is shared is the number of times to multiply it. So it's shared 3 times. So 2 is shared 3 times. So then I must 2 times 2 times 2. What is 2 times 2 times 2? 8. So GCF is equal to 8. Step 5 would be to multiply, just like we did. Okay, now I'm going to do one without writing all the writing, obviously, and just do one from the get-go with our steps. Okay, so I want to find the GCF of 72 and 84. So step 1 is to what? Step 1 is to, thank you, prime factor. So this is step 1. 72 be 2, 36, 2, 18, 2, 9, 3, 3. So 2 times 2 times 2 times 3 times 3. Now, do not write it with exponents, okay, because then it's hard to tell how many times they have them in common if you do it with exponents, okay? List them out. Don't do it with exponents. Then I prime factor 84. I'll use factor tree. 7 times 12, 7 is prime. So our factors of 12 are 2 and 6. Factors of 6 are 2 and 3. So the prime factorization of 84 is 2 times 2 times 3 times 7. So that's step 1. Step 2, list the common prime factors in each one. 2 times 3. Okay, step 3, find out how many times they're used, that they're in common. 2's common once, twice. So that means I gotta do 2 times 2. 3 is used once and once. That means I gotta go times 3. Yeah.
Why aren't you using the other two?
Because it's not shared. It's not common with the other prime factorization. It has to be common with the other prime factorization.
Oh,
In other words, yeah, that 2 right there is not there's no more 2's to be common with. So that's why I don't use the last one. Just like the 3 here has no other 3 in common, the 7 here has no 7 in common. So I can't use them unless they're common. Just what?
Are we able to do like inverted division on both numbers?
Yes. Yeah, I'm showing both ways because there's some people that like factor tree and some people like inverted division. So now I multiply. See, let me look at my steps again. Find the number of terms in common prime factors shared in both prime factorizations. Yeah. So this is really 3 and 4 right here. Step 5, multiply. 2 times 2 is 4 times 3 is 12. So 12 is equal to the GCF of 24 and 32. Step 4 and 3 are where we're finding how many times we got to use it, how many times it's in common. All right, now, here's a harder one, and this is why, I don't want you listing out the prime factors or listing out the factors. We have the greatest common factor of 144 and 264. Okay, another reason why you really need to know inverted division. Okay, so you prime factor it. 144. 2 goes into that 72 times. 2 goes into 72 36 times. 2 goes into 36 18 times. 2 into 18 9 times. 3 into 3 into 9 3 times. So I have 2 times 2 times 2 times 2 times 3 times 3. 264. 2 goes into 264, 132. 2 goes into 132, 66 times. 2 goes into 66, 33 times. 3 into 33, 11 times. So that is 2 times 2 times 2 times 3 times 11. This is another way to do it where we list both prime factorizations, one on top of each other, and then I just go through and circle the ones that are common. And so then I take and go 2 times 2 times 2 times 3. 2 times 2 is 4 times 2 times 3. 4 times 2 is 8 times 3, 24. So the GCF is 24. Now, let's look at what happens when you get this scenario. 45 and 76. I want to know GCF of 45 and 76. Prime factor both of them. 45, 5, 9, 3, and 3. So that would be 3 times 3 times 5. 76 be 2, 28, nope, excuse me, 38, 2, 19. So 2 times 2 times 19. Do they have any in common? So no common prime factors. So the GCF is 1. We call this relatively prime. Do what?
Why would the GCS be 1?
Because it has no common prime factors. Top one has 3 times 3 times 5. The bottom one has 2 times 2 times 19. If there's no common prime factor, then the only factors that it shares is 1. Because every number shares 1 as a factor. Because 1 times 76, 1 times 45. And that's why we're calling this the greatest common factor, because if I just said list a common factor, then all you'd have to do is 1 every time, and then that would be it. Yeah, 38, right there. Smart. All right, let's look at this one. Let's say we have 3 numbers. 48, 64, 96. Okay, doesn't change. For the GCF, you just got to prime factor all 3 numbers. So it's 48, prime factor it using the factor tree. That'd be 4 times 12, 2 times 2, 2 times 6, 2 times 3. So I list it out. 2 times 2 times 2 times 2 times 3. 64. 2 times 32. 4 times 8. 2 times 2. 2 times 4, 2 times 2. It's another reason why I don't like the factor tree. They're too spread out, and you may leave one out. So that would be 2 times 2 times 2 times 2 times 2 times 2. The last one, 96, inverted division, 2, 48, 2, 24, 2, 12, 2, 6, 2, and 3. So that would be 2 times 2 times 2 times 2 times 2 times 3. Now the difference here is the prime factors must be common to all 3 prime factorizations. Okay, so here is 2's, here is 2's, there's 2's, there's 2's, and that's it. Because there's a 3 here and here, but not here. There's a 2 here and here, but not there. Okay, so we're done. So now, 2 times 2 times 2 times 2. That would be 16. So the GCF is equal to 16. Huh?
What about those 3?
They have to be common with all 3 numbers. That's why we don't use them. That's what I was saying. You have here and there, but there is no 3 here. So I can't use it. It has to be common with all 3 numbers. Doesn't have to be in a row, doesn't have to be, they could be all over the place. They just have to be common with all 3 numbers.
So it's better for you to line them up so that way.
I just line them up because it just makes it easier.
But each one would need a 3 for them to go together.
Yes. You would have to have another 3 you'd have to have another 3 sitting right here for them to be able to be used. And you don't, so you can't use it. Yep. Now, on this one, let's say I had this, let's say I was finding the GCF of 24 and 30. So we prime factor 24, 2, 12, 2, 6, 2, 3. So that's 2 times 2 times 2 times 3. Prime factor 30, 2, 15, 3, 5. So that's 2 times 3 times 5. Hang on here, I want to use a different one. Say 22. So 2 and 11. So 2 times 11. The only common we have is that 2 right there. So the GCF is just 2. Not 2 times 2. There's not another 2 that's common. So you can't multiply them together.
What if you do 6 times 11? 6 times 5?
Why would you do 6 times 5? Because it equals, no, I did 22, not 30. Changed it. That's why I prime factor 22. Okay? Now, in the directions, they're going to tell you, find the greatest common factor using prime factorization. Find the greatest common factor by listing all the factors. Don't list all the factors. Use prime factorization only. Now, the other thing that they're going to tell you to do is you have to write whether it's relatively prime or not relatively prime. You don't have to do that either. Okay, relatively prime means it just has 1 as a common factor. Okay, that's all that it means. That's the only common factor that it has. You don't have to do that. All I want is the greatest common factor by using prime factorization. That's all I want you to do. Okay, your work is this. 4.2 4.2, 6 through 18, and 20 through 28. Quite a few of those that we did in the notes, so hopefully you took good notes.